Hey everyone, this is Abhay Kumar, and our topic for the seminar is minimum spanning tree. But we'll be covering maximum spanning tree as well, and Kruskal's algorithm to find out spanning tree. So first of all, we should know what is a spanning tree. So a spanning tree is a connected subgraph that contains all the graph vertices with the minimum possible number of edges. And these edges is also called weight. It has weight on it, so its total weight is defined as the sum of the weights of all its edges. So for example, this is a graph, and the first two are a normal spanning tree, but the third one is a minimum spanning tree, and you can easily see that it is having minimum weights. That's why we can call it a minimum spanning tree. So to help us identify this minimum spanning tree, which contain all of the vertices of the initial graph and no cycles, we use Kruskal's algorithm for that. So we'll be covering Kruskal's algorithm deeply in further video. So let's take an example to understand Kruskal's algorithm. For example, this is you, and uh, keep this scenario in your mind so you can easily understand it. And you are stuck in an island. So now what you need some woods and logs to create a hut, and for that you have to go somewhere and take those logs and make a hut. So you went somewhere and you find few possibilities, few logs there, and you see that they are of different sizes and length and different weights. So you see and say that this one is bigger wood, so you don't need to use another. So you cannot lift it, and it is too heavy for you to lift. So what you will do, you will go for a smaller one. Exactly. So among these, which one is the smallest? This one, which I'm making a circle right now. Yeah. So you take this. Yeah, you take this first. Then you go for a second one, which is a second smallest in this group. Then you go for the third one, and lastly the fourth one. So this is how you segregated it and made your hut. So now, what if I say that this is all about Kruskal's algorithm? Yeah, you heard it right. This is what we do exactly in Kruskal's algorithm. You might be thinking that I'm joking or something like that, but no. This is how Kruskal's algorithm and it is, and how it easy it is. So it will be more easier if I show you some examples further. So let's take this graph as an example, and we have to find a minimum spanning tree in this. As well as the minimum cost, we'll be seeing how we can calculate the cost also. So let's get started. First of all, we have to find the smaller among these. If you remember what we did in the log case, similar to this we have to do in the graph also. We have to go for the smallest edge. If we see, we can easily see that E and D node having edge 1. So we'll make that edge right here. E and D having edge 1. Second smallest is node C and E connected by edge 2. Yeah. So now we'll make this one also. Now moving for the third one, which is F and E node having weight 3. Now here comes the catch. If we are going for the fourth one, C and F node, you'll see that it is making a loop which is not acceptable. We don't need this loop, so we have to ignore that. So after that 5 is coming, 5 as a weight, and CD as a node, but that is also making a loop. So we have to ignore this one also. Moving on to the next one, which is B and F node, and you can easily see it is not making a loop, so we can make it here. So it's partially completed. Now going for the second one, which is A and B as a node and 7 as a weight. So now you will see that we have covered all the nodes. So consider this as completed. We don't need to go for another one. Yeah, about calculating the weight part, you just have to add all these value which is mentioned on the edge, which is 7 plus 6 plus 3 plus 2 plus 1, which is 19. So this is the minimum cost. Now a common doubt arises here, which is, if two edges have same weight, how should we proceed? So it is not that much complicated. You just have to take one node, one edge, and keep proceeding as you were doing in previous examples. So you can start with anyone, and you have to just take care of the loop. That's what the important part. Now moving on to the second example, consider this graph, and these are the weights which is mentioned between two nodes. So for each edge, if it does not create a cycle, we add it to the minimum spanning tree we are creating. So we know this rule from previous examples also. We keep doing this until all the vertices are present in the tree we are spanning. Exactly. Now first is A and C node, which is having minimum weight. Second is B and E node having same weight 3. So we'll add that also. Now if we see fifth A and B node having 5 as a weight, we cannot draw it, we cannot add it, because it is making a loop. So we have to ignore that. After this we have D and E node which is having C as a weight, so we'll add that. So since we are doing this in ascending order, this is termed as minimum spanning tree of the above graph. Similar to this, we can also make a maximum spanning tree. We just have to start with a greater number in the first. So moving on to the application part, minimum spanning tree and Kruskal's algorithm basically is used in computer networking, like solving complex networking problems, and in uh, in a city, like connecting roads and all, you can use this. About the implementation part, we will be using Java, and we'll see the output. How is it going, like how can we calculate the minimum spanning cost and all. Yeah, so this is public class vertex. So we defined data and visited, and we'll just compare. Yeah, in this one we just compare ascending and descending, like that. Yeah, source, destination, and weight, we already familiar with these terms in previous examples. Yeah, so compare to is it basically compares. It's important to make minimum or maximum spanning tree. Yeah, for making maximum spanning tree, use the below mentioned code, and for the minimum one, use the above mentioned code. This is public class Kruskal's algorithm. So this is the graph that we were talking about, and after running all this code we'll get a output which is telling that minimum weight is 14.